we have a rational expression and we want to see when is that expression greater or equal to 0. So we're going to apply the same strategy. First, is one of the sides of the inequality equal to 0? It is, the one on the right hand side. Now that we have that, let's set the numerator and denominator equal to 0. Well, let's start with the numerator, which is x plus 6. Let's set it equal to 0. And if we subtract 6 to both sides, we're going to get a value, -6. And now let's set the denominator equal to 0. And let's try to solve. Well, here we have a trinomial, and the highest degree is 2. Let's try to solve this by using factoring. Let's try to find two numbers that if we multiply, it is equivalent to -24. And at the same time, those two numbers, if we add them up, it is equivalent to -5. Well, those values are 3 and -8. 3 times -8, it does give us -24. And 3 minus 8, it does give us -5. So now let's rewrite our denominator. We can rewrite it as x, and the first value in our combination, which is plus 3, times x, and the second value in our combination, which is -8. That is equivalent to 0. Now let's solve. We can set each multiple equals to 0. So on our first, let's take away 3. So now we got one solution, which is -3. Then on the other, let's add 8. And we obtain a value of +8. Now that we have those values, let's create intervals in the number line. So here, let's draw our number line. And let's estimate their location. Well, let's say that -6, it's somewhere around here. Well, then -3 should be more to the right-hand side. So let's say it's around here. And +8, oh, that must be all the way to the right-hand side. So let's say it is somewhere around here. So those values, which are from -infinity to -6, let's call them interval 1. Those values from -6 to -3, let's call that interval 2. Those values from -3 to +8, let's call that interval 3. And those values which are greater than 8, let's call that interval 4. So now let me erase some of the work that we have done to start testing values in our interval and get our solution set. For the first interval, choose any value that is less than -6. I'm going to choose -10. So let's plug it into our rational function. So the numerator is going to be 16 and the denominator is going to give us 126. Well, now let's ask ourselves one question. Is the result that we obtain greater or equal to 0? Well, in this case, it is true. Well, because it's true, then we know that we are going to get solutions in this interval. So let me highlight that interval. Now let's test interval 2. Choose a number that is between -6 and -3. I'm going to choose -4. Now let's plug that in. So the numerator is going to give us 2, and the denominator is going to give us 12. So now ask yourself this question. Is this greater or equal to 0? So this is true. So we know that in this second interval, we're also going to identify solutions. Now let's test interval number 3. Choose any number that is between -3 and +8. I want to choose the easy one, 0. Let's plug that in into our rational. So we're going to get 6 on the numerator and -24 on the denominator. Now let's ask ourselves one question. Is that greater or equal to 0? Well, this is false. So there will be no solutions in the third interval. Now let's test interval number 4. Let's choose any number that is greater than 8. I want to choose 10. Let's plug that in our rational. The numerator is going to give us 16. The denominator is going to give us 26. So now let's ask our question. Is that greater or equal to 0? Well, this is true. So we know that we're going to get solutions in the fourth interval as well. So we are done. All the solutions are going to come from the interval 1, 2, and 4. So now let's test endpoint. What would happen if we use the value of -6? Well, if we do, the numerator is going to give us a value of 0. Well, when we compare it to the inequality of greater or equal to 0, this is actually true because we are now using the equal sign. Then we can include the value of x equivalent to -6. So let's show that in the number line with a filled circle. Well, remember that the value of x equals -3 and x equals +8, they made our denominator equal to 0. So we cannot include those values in our solution set because that will give us 0 in the denominator, which is undefined. So let's represent that as a whole circle. So now let me give myself some space on the right to write down our solution. So it is the first interval, which is from -infinity to -6. But we can include -6. So let's do that as a square bracket. And then union our second interval, which is from -6 to -3. But -3, we cannot include it. So let's do a curved bracket. Union, and then from +8 to +infinity. But remember that we cannot use +8, so let's do a bracket. So we are done. So just a side note, we can rewrite this in a shorter way. Because notice that -6, it is used in both of those intervals. Then we can just call this a big interval from -infinity to -3. Either or, they are both correct. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.